Hello everyone, welcome to the first lecture on single variable calculus. Today we are going to be talking about the limit of a function. Let's get started. So let's begin with the idea behind a limit. So basically the question that we're asking is, what does our f of x value approach as our x value approaches a point? So we can take a look at a couple of examples. So if we're looking at a polynomial, like this quadratic, when we take a limit, we're basically just saying, what is our f of x value at any x value? But when we get rational functions with asymptotes, this can also be applicable to trigonometric functions. We kind of get these undefined areas, and limits can help us find, determine what happens at that point. And then also with jump discontinuities, limits can also help there as well. Alright, now let's take a peek at some limit notation. So in words, what we say is that the limit as x approaches c of f of x is equal to L. But in limit notation, we can write the limit as x approaches c of f of x is equal to L. So we put this LIM, then we put our variable arrow to our constant x value, and then of our function is equal to our limit. Alright, now let's talk about some limit evaluation. So here's an example. Let's take the limit as x approaches 3 of x to the 5th plus 3x to the 4th plus 5x to the 3rd plus 8x squared plus 10x plus 7. So when we have a limit of a polynomial or rational or basically any type of continuous function, we can just plug in this value for x and substitute. And for this example, it will give us 730. So we can say that the limit as x approaches 3 of our function is equal to 730, or we can say that same thing, but in our limit notation. So now let's talk about some one-sided limits. So one-sided limits are limits that we can only approach from one side. So let's say we have a graph like secant of x, say. I'm only going to draw a little bit, but here we have secant of x. That's a bad drawing, but if we want to approximate this value here, well, if we're coming in from this side, secant of x is going to go up. If we're coming in from this side, secant of x is going to go down. So one-sided limits allow us to approach a discontinuity or a point from both sides. And if we have the limit as x approaches a of f of x is equal to L from the negative side, and the limit as x approaches a of f of x is equal to L from the positive side, then we can say, and only then can we say, that the limit as x approaches a, no superscript because this is from both sides, of f of x is equal to L. That is our definitive limit. So let's do some one-sided limit evaluation. So we're going to take the limit as x approaches 0 from the positive side of 1 over x. We take a peek at our graph. We are going to see that at x equals 0, we have an asymptote. So what we are going to say is that as we come in from the positive side, so if we're coming in from over here, what's our function doing? Our function is going up. Our function is going up because we're on this side of 0. We're on the positive side of 0. So that means that we are going up to positive infinity. We can say that the limit as x approaches 0 from the positive side, 1 over x is equal to infinity. Now let's do another example. So if we take the limit as x approaches pi over 2 from the negative side of tangent of x, we can take a peek at our graph, and I only did a couple of tangent lines because we're only interested in the area in between. So this asymptote here is at pi over 2. And we want to see what's happening when we come in from the negative side. So if we're coming in from here, coming in from here. What's our function doing? It's not going down. This one is going down, but it's not. We're not dealing with this side. We're dealing with this side. So our function is going up. So we're going up to positive infinity. And notice how I didn't say how the limit. So when I write this, I'm going to write the limit as x approaches pi over 2 from the negative side, not the positive side, because if we had the positive side too, then that means our function would look something like that. But it doesn't. We have this. This goes down here. So we're going to write with the negative tangent of x is equal to infinity. So that is it for our intro to limits. Next time we will be talking about some properties of limits. Very exciting stuff coming your way. By the way, this graphing software is called Manim. It's super cool. I recommend, if you're interested in coding with Python, that you try it. Please like and subscribe. We hope you enjoyed the video.